morning, children. Welcome to the online class. How are you, children? Children, in our previous class, we have discussed magnetic force from a field force. Under a field force, we have discussed magnetic force. There are two more field forces, children. They are electrostatic force. Electrostatic force. And third field force is gravitational force. Gravitational force. Children, force. First of all, you should know the unit of force. Force is always measured in newtons. Force is always measured in newtons. If suppose I am using this chalk paste to write on the board, so I need to exert some force. So that force may be measured, and it is going to be measured in the unit of Newton, children. So if I want to rub the board, I want to rub this serial number 3. So I want to use some force. That force also measured in newtons. If you want to kick the football, any kind of activity by using your body muscles, and along with this, other field forces are also measured in newtons. So the SI unit of force is newtons. SI unit of force is newtons. Force is always measured in newtons. So electrostatic force. What is electrostatic force? The force exerted. The force exerted by a charged body. The force exerted by a charged body on another charged body. On another charged body is called electrostatic force. So the force exerted by a charged body on another charged body. This definition is of electrostatic force. Right now, we'll see example regarding the electrostatic force, and you may get clear idea about this definition of electrostatic force. Children, you take a balloon. You take a balloon and inflate. And inflate means allow the air into the balloon. So you know that if you allow the air, if you blow the air into the balloon bulges. The balloon bulges. Then you tie up the mouth of the balloon. You tie up the balloon mouth. Right now, you take a paper. You take a paper. So a paper like this. You take this paper and cut into small bits of paper, very small bits of paper. Okay, children, you take a paper, a 4-sheet paper or any paper, and cut into small bits of paper. Okay, children, and you take one more paper. You take one more paper, and this is that one more paper, children. So you want to take this paper and you want to rub. You want to rub on the balloon. If suppose you assume that this duster is a balloon for some time, and you rub with this paper on the surface of the balloon like this. When you are rubbing on the surface of the balloon like this, the surface of the balloon acquires an electrostatic charge. Right now, I can say this balloon is on a charged body. Right now, the balloon is in a charged body position. It is a charged body. Right now, you take this balloon near the bits of paper. Previously, you have made the entire paper to cut into pieces, no? Then you allow the balloon to near to the cut pieces of paper. Then this is a charged body, and this charged body applies some force to that bits of paper, but this force we cannot able to see that, children. But actually the force exists between these two objects, but we cannot visualize it. So oppositely, all the papers, all the bits of paper will rise into the air and cling to this the surface of the balloon. Means they will attract or attach to the surface of the balloon, children. One more activity is, comb. We use comb to comb our hair. So you try to comb your hair for a minute. After combing, you take that comb and you also cut a pieces of paper, like how we did in the first activity. Then again you bring that comb near to the bits of paper. Some of the papers will be attracted or pulled towards the comb, children. This is nothing but electrostatic body, electrostatic force or electrostatic body. Why it done? Why it happened? Because first, previously the balloon is a charged body, and when it is come closer to that bits of paper, they also attain, they also possess, they also acquire a charge from this charged body. Then it acts in the opposite direction. So this duster, this balloon is acting in this direction, and all the bits of paper will act in the opposite direction. So all the bits of paper will rise and cling, will attach to the surface of the balloon, children. Right now you got the meaning and you got understand. The force exerted means applied by a charged body. Who is a charged body here? This is a balloon. Assume this is a balloon on another charged body. The paper bits are another charged body. Yes, they also gets charged. Why? Because it is providing the charge to the bits of paper, but they act in the opposite direction. That is the reason all the bits of paper are attracted towards the surface of the balloon. This is all about electrostatic force. Right now it's the gravitational force. What is gravitational force? So children, I'm taking this pen, my pen. Okay, if I doing like this action, suddenly it slips off from my hand. Then where it is going to be landed, children? On another planet like Mercury? No, children. It lands on the floor. Okay, when it is slipped from my hand, why a force is responsible and that makes the pen to fall down? Is there any force exists, children? Yes, there is a force existed there. That's the reason your pen slips off from your hand and it is pulled towards the earth, children. It is pulled towards the earth. But suddenly you make a magic and this pen is on the table, children. Even though it is on the table, continuously the gravitational force pulls the pen, but it is supported by the table, children. If suddenly the table was disappeared, again it is going to be fallen down, and it is again supported by the land, children. It is again supported by the floor or land. Okay, children, this is all about gravitational force. Right now I am using this chalk piece to throw into the air. Why, children? It again coming down. See, it is coming down and it is fall down. So I am thrown and it is landing on my hand. If there is no hand support, what it happens? It directly falls on the ground, children. Understand? So every object which is thrown into the air will come back again because of a force called gravitational force. This gravitational force pulls every object which is close to it, children. Understand? Our earth is very massive and it is very huge, children. So whatever the object is present on the earth and other than a distance of earth, they are all pulled towards the earth, children. This is what we called as the force of gravity. And children, you should also know that there is a force, what we call, children, force of attraction. Yes, there is a force of attraction between any object, children, in this universe. So children, there is a force of attraction between the blackboard and me right now. There is a force of attraction between one person to another person. There is a force of attraction between the wall and me, but we cannot assume and we cannot see that force, because that is very small force when compared to the gravitational force, children. But actually there is a force of attraction between any of the object, children. Between any of the object in this universe, there exists a force of attraction. So children, right now we see lab activity. You understand the concepts of electrostatic force and gravitational force. So we'll look at lab activity. To find the limiting force. To find the limiting force born from thread. So children, here is our aim. We are aiming to find the limiting force that born from a thread. So children, we have to find the limiting force. What is this limiting force? I'll give you an example. Children, if you are able to weigh the load of 2 kgs, you are a small kid and you have you can able to carry a 15 kgs weight. If I make you to carry the 25 kgs of weight, can you, children? It is a big burden. You cannot do it, children. Yes or no? In the same way, here to find the limiting force that born from a thread. Okay, children. And again, I am going to give one example, children. See, there is a rubber band. You can stretch the rubber band up to that extent. Okay, up to that extent you can stretch the rubber band. After that, you can if you make the rubber band to stretch even more, what will happen, children? There is a lot of pressure and there is a lot of pressure on it, and it may break, children. In the same way, to find the limiting force that born from a thread, here we are going to do an activity that we are knowing that limiting force, up to what extent the thread can limit its force. So for this you need some apparatus. They are spring balance. Weights, and I am writing here, children, weight hanger and threads. Here we are going to take different types of threads, not one kind of thread, children. Okay, children, silk thread, cotton thread, nylon thread, like that we are going to take different kinds of threads, children. And you are going to know that which kind of thread has a greater limiting force. Okay, children, which kind of thread has a greater limiting force, you are going to learn by this activity. Children, this is a little bigger, children. We'll discuss in the next class, children. Thank you, children.
14 minutes.